Hey, I'm Steven, and I've been getting some requests to do a walkthrough of my flamethrower. Last Maker Faire, 2014 New York Maker Faire, I brought a flamethrower that went on my back, and it was wrist mounted, and I'd shoot fire out of my hand. And I've been getting some comments and people that would message me asking for a walkthrough. So I'm going to give you guys a walkthrough of how it works, how I designed it, all the inner workings of it, and yeah, here we go. Alright, so this is the inner workings of the Model 2 flamethrower. So there are two main systems in the flamethrower. The first one is gas and the second one is electricity. So the first one is gas. In the center of the backpack you can see there's this big propane tank. This is a standard camping size propane tank. You can buy it at a hardware store, Ace Hardware, whatever. It's like $3 or $4. And this is attached to this guy up here, which is in this white 3D printed mount. And this valve right up here is actually what people will get for if they want to be using a propane torch, but they don't want to carry the tank with the torch. They want to keep it on their hip. This is essentially an extender for the tank, and then at the end of this there's a fitting that'll go on the torch, and they can just hold the torch in their hand and use that tooling, and this will stay on their hip, so they don't have to carry the whole thing around. So what I did is I bought this and I just cut off the end. This is an easy, secure, reliable attachment I knew would go on the propane tank. So I took that, spliced the tubing, and I also have a manual adjustment valve that I can use for a safety on and off. So the gas from here goes around, and this is a pinch valve that I designed. This is also 3D printed on my Solid Oodle 2 Pro in white ABS plastic. I think it's 200 micron resolution. And in here's a little servo, and when the servo twists, it pulls the top half down and it pinches the tubing in half. Like if you have a garden hose that has water running through it and you pinch it in half, no water is going to be able to go through it. So it's the same idea, and this was gives me an ability to control the gas flow. And this servo is controlled by the Arduino here. After it goes through the pinch valve, this tubing goes all the way around the tank up to this guy, and this is a seriously heavy-duty 12-volt solenoid valve. It's normally closed, so when I'm not putting any current through it, this thing is completely shut off tight. There's no gas running through it at all. And then when I put 12 volts on it, it opens up. And down here, this is a ghost of batteries past. I had a big 12-volt lead-acid battery. It was like a 100 amp, or not, oh no, it was like 10. It was 10 amp hours, 100. And this guy was able to put out the current to run this thing. So I had a dead man switch in my hand, and I was holding it and pressing down the button, and as long as I was holding it down, the gas would flow. But if something went wrong, I'd just open my hand, and all the gas would completely shut off. So then after it goes through the solenoid valve, it goes up around here, through this long tubing, and then down to the palm piece. And this gauntlet would attach onto my wrist, my forearm, and then the gas would come out of the nozzle here. Alright, the second system in the flamethrower is the taser system, and this is for automatic ignition. So I don't want to have a lighter out when I'm turning on the flamethrower. That doesn't look nearly as cool as having just pressing a button on the side of my finger and causing a 15 million volt spark to jump across and ignite the gas automatically. So connecting to the Arduino is a small little relay board, and when I send a quick 5-volt signal to the relay board, it'll click on and it'll allow current to run from this 5-volt battery I got from a taser that I bought on Amazon for like 15 bucks. This battery, which is connected to this power strip for recharging, then goes over to this mysterious black box that you put 5 volts in and you get 15 million out, and I'd love to know what's in it, but it's encased in this resin and I have no idea what's inside, but all I know is I get 15 million out, or somewhere, it's probably more like 200,000, but regardless, a lot of voltage. So this relay turns this 5 volts on and off going into this, and then from these two leads, these connect up, go all the way across this tubing down to the hand, and then that spark jumps right across the nozzle, igniting the gas. Now the way that I control how much gas comes out is with this board on the hand. So when I pull my wrist back, it pulls on this hemp cord that I have here. This is what was available to me at the time. I definitely understand it's not the best choice, especially with fire. But when I pulled my wrist back, it would pull on this cord and it would slide this slide potentiometer back and forth. And this spring is here to bring it back to its original position. And then the signal from this potentiometer from these 3 wires goes back through this very long blue cable back to the Arduino board. So I was able to read how far forward this potentiometer was with the Arduino. And based on the position of the potentiometer, I was able to move the servo and control the gas accordingly. So I would be able to move my wrist back and forth, and it would control how much gas comes out. On here I have a 7-second display, and this would light up increasingly as I had more battery, so if I was low on battery, only 1 or 2 segments would be lit. And then this button is a calibration button, so I would hold this down and move my wrist to my maximum capacity, my farthest back and my farthest in, and then the Arduino would automatically calibrate the max and min value for the potentiometer to be full gas and no gas. So if somebody's hand were maybe a little smaller, didn't have as much range, they'd put it on, they'd calibrate it, and they would still be able to get full fire even if they couldn't pull it all the way out because they would have calibrated it. So this allows anybody to put it on and use it. And the last thing about this is the custom steel gauntlet that I built. So this here has this mechanism where I can pull this piece of metal back and it opens up, and then if I push them together, it'll snap back in place. And this is, I welded this with a welder I built out of 2 microwave oven transformers that I rewired. And it's not the cleanest welds and I'm not the best welder, but it does the job. So I can push this down, it'll open it right up, I can put my wrist in, and then just snap it closed, and I'm securely in, but very easily quick release to get out. Just a spring for this return action for this lever here. And it's very easy to put on and off. Alright guys, that's a walkthrough of my Model 2 flamethrower. I'm going to be working on designing Model 3, which is going to be all on my arm. There's going to be no back component, it's going to be all there. It's also probably not going to be controlled with a potentiometer. I'm thinking about different ways I'll be controlling it, but hopefully I'll be getting liquid propane running it, which would be such bigger fire, which would be really cool. So hopefully I'll get that running. As I start designing and building that, I'll be posting updates and videos and post on my website, stephenhaas.com, so you guys can check it out there. If you guys have any questions, just write them in the comments and I'll respond. And thanks for watching.